Being exposed to radiations directly or indirectly can result in serious health problems like severe skin damage and acute radiation sickness over time. It may also contribute to the development of cancer and diseases that can affect the blood vessels. Therefore, monitoring your level of radiation exposure is essential to ensure the safety. A dosimeter is a device used to measure the radiation exposure. Let's delve into the evolution of dosimeter and one of the dosimeter called the Raysafe Dosimeter. In 1940s, during the Manhattan Project, the US government recognized the need for strict safety measures in nuclear research to develop the atomic bomb. A health division was formed and Ernest Olin, a team member, focused on the tracking radiation exposure. He developed the film-based dosimeter, which is the first reliable device to monitor the cumulative radiation exposure. Before this, worker used pocket ionizing chamber, which is the small tube-like device that measures the radiation by comparing the electrical charges. However, these were error-prone, cumbersome, and only measures the single dose readings, lacking the ability to track the long-term exposure. Now the market offers the wide range of the dosimeter. Each utilizes the distinct technologies to measure the radiation's exposure. Each type of dosimeter has its specific applications, advantages, and the limitations. A Raysafe dosimeter is based on the principle of radiation interaction with a semiconductor. A semiconductor is a material that can conduct the electricity but not as much as the metal. In Raysafe dosimeter, semiconductors like silicon are used because they can react with the radiations by generating the electric charges. When the radiation hits the semiconductor, it causes the electron to move from the place where the electrons are bound to the atoms to the place where the electrons are free to move. This process creates the holes in the place where the electrons was initially placed before its movement. So this process as a whole creates the electron hole pair. When the electric field is applied, electron move toward the positive side and the hole to move toward the negative side. This movement of charge carrier generates the current, which can be converted into the measurable signal in real time. This real-time data is then converted and transmitted into the central hub for the visualization purpose, which can be analyzed the radiation exposure. This dosimeter has high energy resolution and fast response. This is widely used in medical imaging, radiation monitoring, and the nuclear spectroscopy due to its precision and the compactness. Due to these reasons, Raysafe dosimeter can be used widely in medical physics, where radiation is used, such as in X-ray, CT scan, and radiation therapy. These dosimeters can ensure the safety of both patients and medical staffs in real time. Further innovations of this dosimeter are expected to enhance its sensitivity and the integration with artificial intelligence.